In this question, we determine the conclusion of the Rolle's theorem, that is f prime of c equals 0 to determine the value of c. So we have this function f of x equals 8 sine 2 pi x, where x lies between -1 to +1. So let's see how to determine the value of c. So to use this f prime of c equals 0, we have to first find the derivative of f of x, which is f prime of x. So I find the derivative by differentiating the right side expression. That is, we have to find the derivative of 8 sine 2 pi x. Since 8 is a constant, we can use the constant multiple rule. So we just put the 8 as it is and find the derivative of sine of 2 pi x. The sine of 2 pi x, its derivative is cosine 2 pi x, and we should also use the chain rule to find the derivative of the inside expression, that is 2 pi x. The derivative of 2 pi x with respect to x is 2 pi is a constant and the derivative of x is 1, so it's basically 2 pi. So we multiply this constant 2 pi, so we can simplify this. So these are the constant. 8 times 2 pi is a constant. So it becomes 16 pi. And we have this cosine function, that is cosine of 2 pi x. And this is the derivative function, that is f prime of x. Now let's find the f prime of c. So we have to replace x by c. Therefore, this becomes f prime of c equals 16 pi cosine of 2 pi c, and we have to set this up equal to 0. So I'm going to equate this to 0. Now let's consider this as the equation where we can use it to solve for c. So we have to solve for c from this equation. So first, let me divide both sides by 16 pi. This is a constant, so we don't need this. So it is cos of 2 pi c, and this equals 0 divided by 16 pi is a constant, which is 0. So we get this equation, cosine of 2 pi c equals 0. So this is basically a cosine function and it is equal to 0, and this means we have to determine the values of angles where the cosine function is 0. So looking at this cosine function graphically, we see that cosine function is 0 at x equal to, that is pi by 2, and this one is 3 pi by 2, and if you look at the negative side, it is 0 at negative pi by 2 as well. So it is 0 at odd multiples of pi by 2. So we can say that cosine of 2 pi c is 0 when so it is 0 for cosine of pi by 2, and cosine of 3 pi by 2. Can also consider this cosine of negative pi by 2, and it just keeps continuous. Okay, I should put a 0 over here because this is 0 for these values. 0, and this equals, for all these values they are 0. So we can find this 2 pi c. That is 2 pi c equals either it could be pi by 2, 3 pi by 2, or in fact I can write down this negative pi by 2, and so on. So we are just taking only these few values so that we can determine the exact value of c, which lies in this interval -1 to +1. So let's set up this equation. So we have 2 pi c. First, let's consider this pi by 2. So 2 pi c equals pi by 2. Therefore, one of the value of c equals pi by 2 divided by 2 pi, and I can write down this as multiplied by 1 over 2 pi. We see that these two are getting cancelled. So this equals 1 by 2 times 2 is 4. So it is 1 by 4. And its decimal equivalent is 0.25. So this is one of the value. Now I'm going to consider the other value such that cosine of 2 pi c equals 0. So cosine of 2 pi c, that is 2 pi c, when it is equal to 3 pi by 2, the cosines will be 0. So from this also we can determine one of the values of c, that is 3 pi over 2 divide by 2 pi. So I write down this as multiplied by 1 by 2 pi. We cancel these pi's. So it is 3 fourths, because we have 2 times 2 is 4. And this equals, that is in decimal equivalent, it is 0.75. Let's consider the other value, negative pi by 2. So when we consider 2 pi c and this equals negative pi by 2, it's basically we are going to get the negative value of the one which we found for pi by 2. That is, we are going to get c equals negative of 0.25. So we observe that there are about three values, that is negative 0.25, 0. We write this a little bit clearly. This is negative 0.25, comma 0.25, and then 0.75. So these are the values of C that satisfies the Rolle's theorem, which also lies in the given interval negative 1 to 1. We ignore the other choices as given in the answer choice due to the reason either they do not lie in the interval or they do not satisfy the conclusion of the Rolle's theorem.